Hello, here's a drawing instruction video on one way of resizing and rescaling a something that you're trying to draw. Well, a drawing, usually from a photo reference, but here is the basic idea. This first idea I'm going to call more of a proportional idea, where we're really kind of looking at the distance of the horizontal compared to the distance of the vertical of any given rectangle. And this rectangle can represent just a bounding box or sort of anything. And a lot of videos and books and whatnot talk about taking the measure of one and then comparing it to another, and that can get a little confusing, and is in particular is pretty tricky to do in real life. But it occurred to me not so long ago that if I just sort of think of that as finding the number of squares in any given rectangle, that I would be able to transfer that, scale that up, resize it in a way that makes sense to me. So hopefully it'll make sense to you as well. So I've done a little bit of pre-work here, but so if I'm thinking about this first rectangle, one of the things about thinking of squares is that I already sort of have studied measuring squares and how to draw squares, and know that I can use my pencil to measure one side to another and get fairly quick, fairly accurate square. So when I'm trying to when I'm thinking about this rectangle in particular, I want to think about it has one square and there is some remaining. There's a leftover, there's a remainder. And how much is that remainder? Well, if this is the square, I can divide that pretty easily up into 4 fairly equal parts, and I feel like if this is the amount left over, it would be about 1/3 more, probably be about that much, and that would be about 1/3. So once again, it has this sort of about notion, but I'm going to say this is 1 1/3 squares. And I just sort of know that I'm thinking horizontally. I'm not worried about which number has to go first. Is it 3 to 4, or 1 to 2.5, or etc. So then when I'm just sizing that up, I'm going to first start out by making a bigger square. And I have other videos on this, but just real briefly, I would measure the distance. I would start with some parallels, and then I would add one more. I might try to guess what it is first, but eventually I would end up measuring and marking the distance where the last line would go. And I'm going to go quick here, but I could take a little bit of time and test that and measure it and make sure it's okay. So now when I'm trying to add a 1/3, I am going to need to sort of think of this in terms of thirds. And then add on this much again over here. Let's extend that. Something like that. And I'm checking this against my original, and it's close. I can tell I would probably want to, like I said, take a little bit more time and make sure I'm measuring and copying distances accurately. But now I've scaled this up in a way that just involves squares and a little bit of math, not too much math. So let's do another example here. Here's one that's a little bit taller than wides, but it's still the same idea. I'm going to say, how many squares? It's a game. It's the latest game craze that's storming the country. So that is the square. And that is the amount left over. So this will be, I'm going to do a little bit of measuring here and perhaps get my head in the camera. But it looks like it's a little bit even less than a quarter, so it's probably, I know those aren't that accurate, but it's probably 1 1/5. But I promise a fifth is the farthest, is the smallest fraction I'm going to think about. If it's skinnier than a fifth, then I usually say, and others say, yeah, and plus a little extra. Just call it a little extra. I would like to know if that is relatively accurate. And no, not that accurate. So let's see. That's looking a little bit better. So once again, for quickness, I'm gonna move forward, but do take your time and make sure that that seems relatively accurate. And so if this was the add-on, it would be even less than a quarter, because this would be half. This would be the quarters. So I'm going to say it's 1 1/5 squares, and I just know that it's in a tall format. So let's see, I will make a scaled up version of that, and I'll do that starting with a square. So I'm just going to start out with three of the sides, and then measure this one to tell me how far the other one needs to, where the other one needs to be placed, the final line. And I think that's okay for demonstration purposes. I think my lines are getting a little cattywampus, but if that is one square, let's see, maybe I'll make my marks over here so it's I have some more space for that one, which now that I think about it, it's going to be interesting where I place that. Maybe I'll size it down. So let's see. That's pretty close to half. I'm trying to find basically a fifth. I think there's an alcohol joke in there somewhere. So once again, I would measure these and take a little bit of time to make sure they're okay. And perhaps about there would be a fifth. It's going to be smaller than a fourth. So I want to take this and add it on up here. And even that seems a little big. It's good to get the whole thing drawn out. So yeah, this definitely looks like sort of a skinnier rectangle than this one is. So I will use my eyeball and adjust and correct a little bit here. Seems more like that to me. But even sort of being able to check to make sure that your square is actually fairly accurate is something that's relatively easy to do. And once you know that you've replicated that fairly accurately, then this remainder is a little bit easier to it's a little bit easier to just gauge that. So let's see this last one here. I found the squares a little bit earlier, and I think I was deciding that this rectangle is 2 and about 2/3. Maybe more like 3/4. If I take this, so I have this square, and this is my remainder left over. So I want to check out this distance as it relates to one of the squares. Yeah, and that is seeming more like about 3/4. So this distance from there to there is what I'm figuring out, because that's the same distance from there to there. So that's 3/4 of one square. So I'm going to say this is 2 3/4 squares. So I could do that with a square and a square and then 3/4 of a square in a similar fashion to this, and in a larger size. But I think I will scale it down just because there's not a whole lot of space to do a scaled up version. So let's see. That's my first guess at a small square, and this is going to be nice and pinchy. It's a little too small to measure that easily, but the concept is the same. I'm going to say that's basically a square. And then we'll add another square. And then I want to add on 3/4. So to find 3/4 of a square, I'll use this one. It's about that distance. So let's add on that amount. And once again, I would take time and be a little more careful with measuring. But now I have a decent approximation of a scaled down version of this rectangle. I'm eyeballing it, and it seems like the squares are a little wide, but yes, a little bit of adjusting. So that is one way to size up the outer bounding box. And when you are trying to figure out where to place something in all of this, what I'll do is I will just create sort of a random object. And what I'm going to do to help me place these points is to bisect both sides of my bounding box and then compare them to proportionally where they fall on the edge. So this point right here falls on the it's kind of fun fact that 1 1/3 is kind of the same as, never mind. It's already sort of helped me figure out where the 1/4 is. But I'm going to transfer, I want to break up this side so I can kind of see that this point is just to the left of the halfway mark. So that's going to be about there. This point looks like it's just above the halfway mark over here. I didn't actually do those yet. So that one looks like it's about halfway, a little bit above half. this point here, one thing that's throwing us off is these my original square marks a little bit. Well, I don't know if it's throwing you off, but it's throwing me off. So let's see, that one was a little bit to the left of the half. This one is going to be lining up pretty close to the halfway mark. Whew. I think technically these should be lined up, these marks, and they're decent. Yeah, I guess they're okay. Did I mention taking time and measuring out? Anyways, and then this point over on here is pretty much at the fourth. You live over here. I'm talking to my points now. Could also just quickly bisect, so I have a better idea. Anyways, the idea is to use a square and the remainder, and then by bisecting the sides, getting a pretty quick and fairly accurate idea of how to size up the object or objects within your bounding box that you've already sized up. Let me see if I can do another one here and confuse myself even more. So I want to think about breaking that down into quarters, as well as the whole side over here. So now I can make sure that I have the same information on my new sized up bounding box. And same over here. And then I can start placing my points. This one is a little bit, it's kind of there, almost a third over for that second half. Let me see, this one, I want to make sure to use, not these guys. Those are fun. So this one is going to live about 1 1/3 down. Let's see. That's 1. That's 1/3. This one is going to be about half. How did that guy show up? Where was he from? Anyways, I'm not quite positive, but oh, that's why it's supposed to be over here. Not sure what that was from. hopefully this is helping you realize that it takes a decent amount of thought and that to not feel bad if it's confusing you, because it can be kind of confusing. But that point is there, that point was about there, that point is about there, and that one's about there. So that's decent, and I'm also checking out the negative space to help me judge if these seem, just how accurate these seem. Seems like it might be a little bit down there. That seems okay, and so does that for now. So that should help you scale things up and potentially scale things down. Just resize in a proportional fashion using no-nonsense, non-threatening squares. Okay, thanks.